So 7.1 and 7.2 is all about exponent rules. So as a bit of a recap, let's look at some of the rules we learned yesterday. When we're adding and subtracting terms that contain exponents, we use a rule called combining like terms. With this rule, all we do is we add the coefficients together, the numbers in the front. We don't change the bases and we don't change the exponents. When we're multiplying things together, we're multiplying two things together that have the same base. And using this rule, you add the exponents. So it's called the product rule, but what you're really doing is adding the exponents. Then when you're dividing, you're looking at two things that have the same base, and you subtract your exponents. Top exponent minus bottom exponent. And then finally, we learned something called the power rule. When you're taking an exponent to an exponent, you multiply those together. So we've got a lot of rules with a lot of weird things going on. Our product rule, when we multiply, tells us to add our exponents. Our division rule, our quotient rule, when we divide, tells us to subtract our exponents. And when we're taking exponents to exponents, we're actually multiplying. So how are we supposed to keep this all straight? If you're not having any trouble at all remembering these rules, close your ears for a few minutes. But if you are having trouble trying to remember, when do I add? When do I multiply? When do I do nothing? I have a little trick that might help you. So this is on the top of Tuesday's page. And this is a trick I've used with my college students, and they love it. So this is a trick for all ages. I even use this sometimes to help me remember the rules. Does anybody remember PEMDAS?
Yeah.
So the order, as you can see here, starts with P. What does P stand for? Parentheses. And then E.
Exponents.
And what are M and D?
Multiplication and division.
And then A and S?
Addition and subtraction.
Perfect. So we've got parentheses, exponents, multiplication and division, addition and subtraction. And this tells you kind of the order, the hierarchy of operations. Parentheses are like king, they come first. Exponents are really important, they come second. Multiplication and division comes third, addition and subtraction comes last. This should be pretty familiar to you all. Multiplication and division are kind of like one step, because division and multiplication are just flip sides of the same coin, right? Division is just reciprocal multiplication, right? Keep, change, flip. So you end up multiplying anyway. So division and multiplication are basically the same operation. Also, addition and subtraction are the same operation, because subtracting is just adding a negative, right? So they're the same. So PEMDAS really only has 4 steps. And you can use PEMDAS to remember your exponent operations. And here's how you do that. If you're using the power rule, what you're doing is taking an exponent to an exponent. So our main operation is this second exponent. So we're here. The operation we use on the exponents is we multiply. So when you're dealing with a second exponent, you go down a step in the order of operations and you end up multiplying. Now let's look at our next rule. If we're multiplying or dividing, if that's our main operation, then what you do to your exponent is you end up adding or subtracting. So if you're here multiplying or dividing, what you do to your exponent is addition or subtraction. You're going down a step in the order of operations. Then finally, when we're adding or subtracting our terms, we do nothing to the exponents. And you can see that here as well. If we start with adding and subtracting, we go down a step in the order of operations, there's nothing there. So this is a little way that might help you remember. If you can remember your order of operations, you know, exponents are above multiplication, division, and then addition, subtraction. Think to yourself, what does this problem have in it? If this problem is a problem that involves, plus signs and minus signs, we go down a step from addition and subtraction and we do nothing with our exponents. If my problem involves multiplication, I go down a step to addition. If it involves division, we go down a step to subtraction. If it involves exponents to exponents, we start at exponents and we go down a step to multiplication, right? So it's just a little trick that might help you remember if you need help remembering it. If you don't need help remembering it, completely forget that I said anything. Okay, so let's move on to what I really wanted to get to today. I promised you that we would talk about 0 exponents. An exponent of 0 just turns your base into a 1. So let me zoom out so we can see this. Any base to a 0 exponent is just equal to 1. It's kind of like, think about when you multiply anything times 0, it just equals 0. It's just a little rule like that. So we're going to do a few quick and easy examples. In these examples, we want to simplify the expression as much as we can. So in number 1, this is a softball question. X is our base, 0 is our exponent. Anything to a 0 exponent is just 1. So our answer here, easy enough, is just 1. So not trying to trick you. Example 2 is a little trickier though, because we do have a base and an exponent, but notice the 5 out front. The 5 out front is not part of the base. Remember, the exponent affects only what it's directly touching. So A is the base, but 5 is not. So for this one, A to the 0 becomes 1, but we still also have this 5 here that isn't part of the exponent expression. So our answer becomes 5 times 1, which is 5. One moment. For example 3, this one looks a lot like example 2. It's got all the same numbers and all the same letters, but there's one big difference. We do have our exponent here, but notice the thing that the exponent is directly touching is this parenthesis. And parentheses come in pairs, so this whole thing in between both of those parentheses is our base. So when we say that a 0 exponent turns your base into a 1, it's going to turn this whole thing into a 1. So look at the difference between number 2 and number 3. In number 2, we ended up with the answer 5. And in number 3, we ended up with the answer 1. And it's all because of those parentheses. So you need to be careful, make sure you identify what your base is before you start simplifying these things to make sure that you get all the pieces simplified properly. Question 4 isn't as hard as it looks. Normally, when I have a lot of things multiplied together, it helps me to rearrange them in an order so that things are grouped. And if you look ahead in your packet at some of the work you'll need to show for the Kahoot or for the quiz review or even for the learning check, you'll see that the work you show actually has a line for grouping your terms together. So we're going to do that here in example 4. We want to put things together that are similar to each other, like have the same base, for instance. So I'm going to take this 3, and then imagine there's a -1 here. And I'm going to put the 3 and the -1 first. Then we've got a couple of things that have x as a base, so x squared and x to the 0. And then we have a couple of things with a y as a base, so y to the 0 and y. So with these, I just rewritten it in a different order. I haven't done any math yet. Let's start simplifying. So we just learned this new rule that x to the 0 is 1. And y to the 0 is 1 as well. So these two things are just going to simplify down to 1. That's really nice and convenient. Everything else just gets rewritten. I guess I could have reorganized this again because now I've got numbers over here and numbers over here, but let's multiply all that together. Got 3 times -1 times 1 times 1. That will all simplify down to -3. Then we have an x squared and a y, and they don't have anything left to combine with. There are no other x's here with the same base. There's no other y's here with the same base, so we can't simplify this any further, and we end up with this answer. All right, that covers 0 exponents. They're very simple. You have to pay attention to where your bases are and what your bases are, but other than that, 0 exponents are very straightforward. Negative exponents, on the other hand, are a bit trickier. So I'm going to zoom out a bit, so it might be kind of tough to see, but you've got your papers in front of you, so you can read along with me. Negative exponents take the base and move it to the other side of the fraction. That's weird, right? We'll do some examples. So if you have a base with a negative exponent, it's moved to the other side of the fraction. And when that happens, the exponent becomes positive. So that's a lot of weird stuff going on, but when we do a few examples, it will make a lot more sense. So I'm just going to go straight into example 1. We start off with x to the 4th divided by y to the negative 5. So the rule we just discussed tells us if you have a negative exponent, it takes your base and moves it to the other side of the fraction. So I'm just going to write this a little bigger so I've got some room to take some notes here. Here's how I approach these problems. If you have a negative exponent, identify the base of that exponent. If you have a negative exponent, identify the base of that negative exponent. That base and its exponent have to move to the other side of the fraction. So this one is starting out in the bottom. So we're going to move it to the top. So that'll look like this. Here's our fraction. Here's our x to the 4th. And here's our new y to the positive 5. So we're going to move it to the top. And in that process, the negative sign in the exponent goes away. And it becomes positive. So what's left at the bottom of that fraction? Everything disappeared. So we would just pretend there was like a 1 out front. We would put a 1 down here, but you don't need to write this, right? Anything over 1, you can just get rid of that 1. So I'm going to go ahead and erase this. Our answer would just be x to the 4th times y to the 5th. Now, this can't be simplified anymore because these are not the same base, so we can't put them together and we're done. In example 2, we've got negative exponents floating around all over the place. So I'm going to write this a little bigger. The first thing I'm going to do is find my negative exponents and identify their base. So I'm going to circle the base of each of those negative exponents. Be careful when you do this. Remember, the base is only what is directly being touched by the exponent. So I'm going to draw a new fraction here. I have a 2 up top that isn't going to move anywhere. That's going to stay right where it is. And I have an x at bottom that's also not going to move anywhere. That's going to stay right there. But the 2 bases that I circled have to switch. Hanging in there? Let me know if you need anything or if you need to go out in the hallway or whatever. So we're going to take the y to the 4th and write it up top. Notice that my exponent became positive when I did that. And we're going to take the x cubed and write it at the bottom, and that becomes positive as well when I do that. So sometimes you're not necessarily done. You might need to simplify things a little bit further after this step. And in fact, take a look at the bottom. We've got 2 things being multiplied together and they have the same base. So it's always helpful to write in your exponent if there is no exponent on one of your bases. So I'm going to make that first x an x to the 1. So there on the bottom, we can use the product rule to multiply together x to the 1st times x to the 3rd. When we do that, what do we do with our exponents? We add them. Okay, so the rules are starting to sink in. Good job. So we get 2y to the 4th over x to the 4th because we added our exponents 1 plus 3. That's our answer. So number 3 is actually a pretty simple problem, but it might seem a bit confusing at first because we have a negative exponent and we have a base that we need to, quote, move to the other side of the fraction. What fraction? There's no fraction here. What do we do about that? You create one. You're always allowed to turn something into a fraction. Thank you to whoever said that. That's exactly right. Everything is a fraction. Everything. I could say that today's March 2nd, right? I could say that the date is March 2 over 1, because 2 over 1 just means 2. So you can always turn something into a fraction. So then when we go to move this We've got our 1 down at the bottom. We move our x to the first down to the bottom. And what do we do on top? Anybody? What do we put up there? Yeah, exactly. In a fraction, whenever things just start to disappear, there's always basically a 1 there. Or another way to think of it is you could pretend like there was a 1 out front in front of that x. So when you moved the x down, the 1 stayed there. So think about it however you want. But this is typically not how we would write our answer here. This is not wrong, but normally we would just write it as 1 over x. Because we don't need, I'm going to do it in red. We don't need this one, and we don't need this one. We don't have to write those. So you just write your answer as 1 over x, nice and simple. So our last example has some parentheses, and we need to think about what that means. So I see a negative exponent, and I need to take care of that. So that -2 is telling me to push that base onto the other side of the fraction. So let's figure out what our base is. The -2 is touching this parenthesis, which has a duplicate parenthesis on the other side. So this whole parenthesis, 3y parenthesis, that whole thing is our base. So when we're talking about what to send to the other side of our imaginary fraction, we're going to have to send down parentheses 3y parentheses squared. Notice my 2 became positive. My exponent became positive. And up here on the top, we have parentheses 2y parentheses cubed. That doesn't go anywhere. That stays right there. So we might not necessarily be done. There might be more simplification that we can do. And in fact, on this problem, I can tell there is. So notice I have exponents on the outsides of these parentheses. These can be distributed inside. So every piece inside that base, all of the little individual bases, need that new exponent. So I'll have a 2 cubed and a y cubed. Then on the bottom, I'll have a 3 squared and a y squared. And when you go to simplify these, I don't want to beat a dead horse, but I see this mistake so often. 2 cubed is not 6. If you wrote down 6, get your erasers out. I just see this mistake. Students start working really fast. They just multiply these together. That's not what an exponent does. An exponent does not multiply. Exponent means take your base and multiply it to itself that many times. So we would take 2 times 2 times 2. And 2 times 2 times 2 is 8. So here we end up with an 8 on top with a y cubed. Then on the bottom, 3 squared is take 3, multiply it to itself twice, so 3 times 3. And that's where we get 9y squared. There's one more thing we can do. We've got a couple of pieces in here that have the same base. We've got a y cubed over a y squared. Those have the same base y. We can use our quotient rule. I keep wanting to call it the division rule. We can use our quotient rule. The 8 over 9 is not affected by this, and we can't simplify 8 over 9, so that's just going to hang out. But for the y's, we can rewrite this as y to the 3 minus 2. Top exponent minus bottom exponent, because this is our quotient rule. We're starting out with division, so we go down a step and actually subtract the exponents. So this just becomes 8 over 9 y to the first, but we don't have to write the 1. So today's already starting to feel a little bit like guided notes, right? We're going to spend the rest of class actually practicing. So we've got 10 skills practice examples. And what I'd like to do today is I want to work through the odd numbered problems with you, but then you should try the even numbered problems on your own, and then you will submit those for homework. So in case we start running out of time toward the end of class, I do want to get this out there. Students who are at home, you will need to snap a picture of this entire page, the notes and the practice problems, and submit that as your homework on Canvas. Students in the classroom, if you get your work done before you leave class, you can just bring it up to me and I'll give you credit right here on the spot. If you don't get it done in class today, you'll have to take it home with you, finish it, snap a picture, and upload it on Canvas, just like virtual students, okay? Is that clear to everybody? So let's get started. So our first odd numbered problem has a lot of pluses and minuses in it. This is a problem where we're adding and subtracting our terms together. So our rule is combine like terms. And in order to do that, our bases and our exponents have to be exactly the same. So I'm going to pick out terms that have the same bases and the same exponents. Notice this m to the fifth and the m to the fifth. Those are the same. I could even write this as 1m to the fifth plus 1m to the fifth. I'm going to put those in the front. So at this stage, I'm just grouping my terms together with like terms. And I'm going to do it with color coding because, as you can probably tell, I'm obsessed with color. All right, so the next thing I see is a negative 2m cubed. Do I have anything else here with an m cubed? Sure, right here. So I've got a minus 2m cubed and a plus 3m cubed. Those are like terms. The next one I see is a plus 2m. That doesn't have any other like terms. There's nothing else in this problem with just an m to the first. But I do have a couple of numbers, a negative 4 and a negative 3. So I've rewritten everything kind of grouped together. And we are going to now actually do the combining. So the 1m to the fifth plus 1m to the fifth, I just add together 1 plus 1. That's it. And that'll give me 2, m to the fifth. Then for the m cubed pieces, I've got a negative 2m cubed and a positive 3m cubed. I add negative 2 plus 3. That'll give me positive 1m cubed. You don't have to have the 1 there. You can just write m cubed. Then for the m term, that doesn't combine with anything. So we're just going to rewrite it. Just carry it down. And then for the numbers at the end, negative 4 minus 3, well, that just gives me negative 7. I don't even have to think about my rules for that one. And this is our answer. We cannot simplify this anymore because none of the terms are like terms. So we can't put them together. So we're done. So we did number 1 together. I want you to work on number 2 on your own, either at the end of class or tonight for homework. And let's move on to number 3 together. So number 3 is a bunch of multiplication. We've got negative 5 times x times y times 4 times x squared times y to the fourth. I know some of it is separated by parentheses and some of it's not, but it doesn't matter. It's all just multiplication, and we can write it in whatever order we want. So we're going to write this with negative 5 times 4 in the front, and then I'm going to put my x times x and times x squared, and then I'm going to do the y times y to the fourth. So I just rearranged it. I put my numbers first, my x is second, and my y is third. That's all I did. And that's just to make it easier for me to see kind of what gets grouped together. So let's simplify. Negative 5 times 4, we don't need a fancy rule for that. Those are just numbers. That gives us negative 20. Then on to our x's. For the x times x squared, what do we need to do with our exponents in this part? Do we add, subtract, multiply, divide? Add them. So what are we adding exactly? Don't forget, you have to fill this in with an exponent if it doesn't have one. So if you forget that, you might end up with the wrong number because you'll forget about that 1. But we take 1 plus 2, that gives us 3, so we end up with x cubed. And we have something similar going on with our y's. One of our y's doesn't have an exponent, so you got to write one in so that you don't forget. This will be 1 plus 4, which is 5. And this is our answer. We cannot simplify this anymore because these two factors don't have the same base. And that should pretty well prepare you to work on number 4 on your own. So let's look at number 5. Number 5 looks pretty crazy. Got a lot of stuff going on here. I'm going to color code mine. So if I'm looking at this fraction, I'm going to write the -2 and the 4 in the same color. I'm going to do the m and the m to the 6th in the same color. And then I'm going to do the n to the 5th and the n to the 4th in the same color. I'm doing that to highlight what gets matched with what. Which of these pieces, which of these bases are we allowed to combine together? So let's start with the easy part. Let's start with the -2 divided by 4. That's just a fraction, right? -2 over 4. We could think about that as a fraction that needs to be simplified. So you could think of dividing the top and dividing the bottom by 2. Or you could think about it as a calculation problem where you literally pull out a calculator, type in -2 divided by 4, and it'll give you -0.5, which is -1/2. So either way you think of it, you're going to end up with a -1 over 2 once you simplify that. Now let's look at the m's. We have an m, which we're going to call m to the 1st, over m to the 6th. This is quotient rule. So with quotient rule, we take our top exponent minus our bottom exponent. But this is the important part. It goes here on the top of the fraction. So you'll put your m to the 1 minus 6 up in the top of the fraction. The same with your n. Your n to the 5 minus 4 also goes in the top of the fraction. Pretty much the only thing left down there at the bottom right now is that 2. We're still not done though, so let's actually simplify this a little bit. We'll have a -1 m to the -5 n to the 1 over 2. And I see a negative exponent. When you have a negative exponent, you have to move that to the other side of the fraction. So identify the base that is affected by that negative exponent, and let's move that base to the other side. So down here at the bottom, we'll now have this additional m to the +5. Did that make sense to everybody? I know that was a lot of steps, and we used multiple rules in this problem. Did that make sense? Okay, I'm hearing some yeses, I'm seeing some nods. That question 5 will hopefully prepare you for question 6. And let's move on to 7. So 7 is also going to be a lot of steps. First things first, I have these two exponents, 4 and 2, which are on the outside of a big set of parentheses. So their bases are huge. Their bases have like a bunch of stuff inside. So the very first thing we're going to want to do is we're going to take these exponents that are on the outside and we're going to distribute them in to each of the pieces on the inside. So we start with the -2 to the 4th, x squared to the 4th, and y to the 4th. So inside that first set of parentheses, I actually have 3 smaller bases. I've got a -2, I've got an x base, and I've got a y base. So all 3 of those things are going to kind of start their own set of parentheses, and each one of them is going to have a 4 on the outside. We have to also do the same thing with the second set of parentheses. We'll have a 3 squared, an x to the 0 squared, and a y cubed squared. Goodness. There we go. Lot of stuff going on, and there are parentheses everywhere, which is making it a bit difficult to see. So let's try to simplify this just a smidge. -2 to the 4th, that's just a number that we can calculate. -2 to the 4th power is -2 times -2 times -2 times -2. And if you punch that into a calculator, you'll get positive 16. I'm also going to do this numerical calculation. 3 times 2, I'm sorry, not 3 times 2. That's the mistake I want you to avoid. This is 3 squared, which tells you to take 3, multiply it to itself twice. 3 times 3 is 9. Then we've got a couple of simple things, like this one here. X to the 0. What is x to the 0? 1. So that's just 1 squared. So that's just 1. So we don't need that. We'll write it here anyway, but we don't need it. So the green piece is 1. And then this one right here is the power rule. X squared to the 4th. That's one exponent, or I'm sorry, that's one base with 2 exponents. When we have that, we have to multiply those exponents together. So we're going to take x to the 2 times 4. We have another one over here, y to the 3rd squared. That's a single base with 2 exponents. We're going to multiply those exponents together. So that'll be y to the 3 times 2. And then finally, we have this y to the 4th. There's nothing special about that. There's no rule we have to apply. It's just y to the 4th. So I did a lot in that step. I simplified some things. I also rearranged things and wrote them in a slightly different order so that I could have some of my terms grouped. Let's simplify this. 16 times 9 times 1 is 144. You can leave that to a calculator if you can't do it in your head. And then x to the 2 times 4 is x to the 8. Y to the 3 times 2 is y to the 6th. And then we have a y to the 4th. So I feel pretty much done. Do I look done? No, there's still something else we can do to simplify. See these? These two factors have the same base. So we can combine them using our product rule and adding their exponents. So we get 144, x to the 8th, y to the 10th. Very nice, you guys. All right, so that was problem 7. You can do problem 8. And let's look at our last example we're going to do together today is number 9. And this one's a bit of a doozy as well, so be prepared. When I start out with an expression like this, the first thing I look for is a negative exponent. And I see a couple of them. So I'm going to circle the bases that are affected by the negative exponent. I see 2 of them. There's an x up top and a y at bottom. We need to move those to the other side of the fraction. So we'll rewrite everything else. The -2 stays at the top. The y to the 6th stays at the top. And that x stays at the bottom. But then the 2 bases that I circled have to switch to the other side. So y to the 4th goes up top, and x to the 5th goes down bottom. All right, let's simplify. We've got some y's that are being multiplied together. They share the same base, so we're allowed to add our exponents. So we get -2 times y to the 6 plus 4. You don't have to write this step out. You can just add in your head. And then down at the bottom, something's happening here too. We're multiplying x's together, so they have the same base, but one of them's missing an exponent. So let's write in a 1. And then we can add those exponents together. 1 plus 5. So we end up with -2 y to the 10th over x to the 6th. All right, and then number 10, you can try that on your own. I do want to say one thing before you get started. For some reason in all the other classes, students have been crushing number 10, but really struggling on question 8. Question 8 has a lot of steps. It is very similar to question 7. So if you try to do question 8 in one step, you're missing something. So try to follow the same steps that we did in question 7.